Yeah, so I actually just made this tweet about how the live streaming on Netflix kind of broke, and a lot of people complain about the stream breaking and buffering and all of that. And I actually wrote a tweet about how even though Netflix is actually the company which is best at streaming movies and TV series and all of that, but still they could not stream a live sport event, although they were like expecting a lot of traffic for this. And I actually wrote about how streaming movies and then the infrastructure that Netflix has built around streaming that is not really suited for live streaming, it's very different from that. A lot of people ask me a few questions about what is different, and although like I did explain a bit of it in my tweet, but it was all words. So let me try to make probably a small video about it. I don't really have the tools to be able to make a proper video. I'm just making it on my S24 Ultra. Yeah, so um, let's try to understand like how the video streaming works itself, right? So if you talk about videos which are pre-recorded, like a movie or a like a TV series kind of thing, so you have the video file. Okay, so it probably starts from 0 point and goes to something like whatever, 2 hours or something like that. So now it's completely all there, like it's recorded, because like you probably buy that movie from a TV studio who has produced that movie, or if it's a TV series, whatever, whoever's producing that, it's a complete file, right? And it'll have multiple tracks in it. So they will, let's say, have a video track, and maybe you will have like two audio tracks, audio right, audio left. Maybe actually you will actually have 7 tracks or 22 tracks for Dolby and all kinds of stuff. So these are all these tracks, and there are also movies that come in multiple audios and multiple videos sometimes. So whatever, like there is a HDR stream and a non-HDR stream. But let's forget all of that for now, and let's just go with something very simple, like one video track, two audio tracks, and then there's this whole file. So what really happens is that you take this and you put it into a transcoder, and it will generate different video files out of it. Maybe you need a 480p stream, you need a 1080p stream, you need a 4K stream, and all of that. And then it will actually depend on a lot of things. So there is the resolutions into formats. So formats, again, maybe there's an H.264 one, which is more compatible with all devices. H.265 less compatible, but can compress things even more to probably like maybe if you're streaming on really old school devices, you might be doing on 3GP. Actually at GeoCinema we do that for very small feature phones, which are just like 1.5 inch screens, and we do that, whatever. So like formats, and formats could be for audio as well. So there is different audio formats available. There's free and lossless audio, there is MP3 kind of audio, there's M4A audio, whatever, different resolutions, different formats. You might make them for different bit rates as well. So you might have like you might have a 1080p at a 1 Mbps stream, and you might have a 1080p at a 4 Mbps stream as well. So even though people select 1080p, but depending on their internet connection and maybe geographic region, you might be giving the different bit rates. So whatever. So you might have like 4 resolutions and 4 formats and 2 bit rates, and you'll end up with probably some 30-40 different kinds of streams. Okay, so you end up with all of these different files, right? So you kind of end up with probably 30 kinds of files, and what you will do is this is what's actually going to be streaming. Now these files are going to be, depending on like the length of the video and all of that, could be like somewhere between 1 GB to, I don't know, maybe 25 GB in size, the different formats, right? You won't upload like a single 25 GB file or even like a single 10 to 1 GB file anywhere, because it's very hard to download such a file while people are streaming that. So what you will do is you will take one of those files, right, and you kind of break that out into chunks. Okay, and each chunk maybe is every 10 seconds of your video, or a different number, maybe every 4 seconds, every 10 seconds, every 30 seconds of your video, and make these different chunks, okay? And there's a different container format, so you don't actually save it in an MP4 or a MKV, these kind of containers, you don't save it in that, and you instead make these chunks which are in probably TS files, and you put them in a HLS format, which uses M3U8 kind of packaging, which means that there will be a file which will have these timestamps. It will have like at 000 and then 010, 020. So that the 0 marker points to this file, the 10-second marker points to the next file, the 20-second marker points to the next file, and so. Now, this is called the manifest. And what often happens is that a manifest has something called a master manifest and a child manifest. The master manifest is a list of all manifests. So you will have a different manifest for each type of video stream. Like the 1080p will have its own manifest, because you need to do this whole stuff for the 1080p. You have to do this whole stuff for the 720p stream as well. And if your player and your whole system supports, you'll probably have different manifests for the audio and the video, so that like if you switch between Dolby and stereo, or you switch between Hindi and English of the same movie, your video stream still remains same, and whatever video was already buffered so far, that remains same. And the audio can simply change. So what that will mean is like net, your whole thing comes down to being a master manifest, okay, which will have linked inside them a bunch of child manifests, okay. So this is just a list of manifests. It will mention that which manifest is for audio, which is for video, what are the different bit rates. The child manifests will actually have the links to the different chunks of the files. And so means in the server, there is like this, there's not a single file, there are separate TS files there, and each thing links to like different parts like that. Now, when you actually play this kind of a file on your video player, on your laptop or somewhere, right? So what happens is you download the master manifest, depending on your settings, which kind of which video resolution you want to play and which audio you have selected, the corresponding child manifests are downloaded, and then the player figures out that which point on the seek bar you are. Like if you are from 0, it will start from the first one, but maybe you're starting from the middle, so it will just start from here and start downloading all the files after that. The interesting part in that is that you can actually very quickly switch between resolutions, because it can happen is that there are two files. So this is like the maybe 720p one, this is the HD one, like as a 1080p one. So it is playing this thing, okay, and you are at this point, let's say. So when you're at that point, maybe change to some of the color, maybe, yeah. So maybe you're at this point, right? And it sees that it is able to buffer a lot very fast, right? And it's seeing that it needs to buffer only the next 30 seconds, but it's able to buffer the next 2 minutes of content really fast, which means the internet speed is really fast. What it does is it keeps that buffer, while also it starts buffering the HD stream as well. And when it is able to buffer 30 seconds of HD stream, it can quickly switch over to playing the HD stream. So your video quality automatically upgrades, and you don't really notice it. And it can do the other way around as well. It can, if it's not able to buffer enough, it'll fall back to the lower quality stream and buffer that, and it's able to buffer that, and your quality switches automatically, and you don't even notice that, right? Sometimes you can explicitly select the resolutions, but even within resolutions, sometimes most streaming platforms, what they will do is they can actually fall back to lower bit rates or higher bit rates if 2 bit rates of the same resolution are actually available. Now, that's streaming for you, and that part is how recorded videos happen. Now, what happens with recorded content, what we call as video on demand, and that's not live, right? So with video on demand, you have the let's say the server for Netflix, okay, and they produce all of this content, and that they put into multiple CDNs, okay, CDN servers, and which are actually distributed all across the globe. So depending on like if you are in the US or if you are in Europe or if you are in, Asia, you might be picking the video files from different CDN servers accordingly. They can actually go a step ahead, in fact, and what they do is, let's say they use something called Open Connect, and let's say some of the biggest ISPs and like an ISP is not like a global thing. Like, there could be an ISP which serves 100,000 people in just one single city. But even those 100,000 people, if they watch something like a very popular content, say like House of Cards on Netflix a lot, this, like in Europe, there are going to be big telecom providers, maybe like Vodafone or something like that, and further they might be distributing to a lot of smaller ISPs, and they further would be distributing to actual end users. Now, if all of these people actually stream, so the total bandwidth that is used here is a lot, and then that kind of adds up here and all. What Netflix has done is that way down there, right? So what Netflix made it possible is that people down the channel, these people and these people can actually cache Netflix's content here. They can say that, hey, so they have this system called Open Connect where there is Netflix's content is encrypted and cached right here. So when you go to Netflix, most of the stuff like signing in and listing your videos, all of that happens by you directly talking to Netflix server. But when you start playing a particular video, the chunks, like these things, when you're trying to get the chunks, those are actually cached right with your ISP. And Netflix even does this thing is that there are some big movie releases, like, or a big show season drop that happens at 12 a.m. They actually pre-cache that stuff before that. So, and it's not like your ISP can watch that movie. It's all encrypted and it can only be watched at 12 a.m. by the consumers, but they pre-warm all that cache, and at 12 a.m. episode drops, everybody's gonna start watching it. It's already there with your ISP. Your ISP does not need to interact with your aggregated large telecom provider, and they don't need to actually fetch it from the CDN, or the CDN does not need to fetch it from Netflix. It's right down to the cache. That's how a recorded video can be done, and this is how it happens to record video. Unfortunately, with content which is live, this stuff can't really happen, right? So you can't actually utilize the ISP or the telecom provider level caches at all, but you will still do something. What you will do is you will have these CDNs, right? Now, the interesting thing about live is that the final end users will have to pick things from the CDN. But how does live actually stream? Now, live is very different. A live does not have it does have a start point when the video actually started playing, but does not have an end point. So it's not like a file which you can say that this is my file and starts from 0 and goes to 2 hour. It's not like that. It's more like, there is a stream going on and this is currently what is playing, and in future there will be more content that will happen. Like, that's actually in the future. It has not even happened. Like, the match has not happened, the punches have not landed, the cricket match has not yet happened, right? I mean, it will happen in actual future and it will get recorded, and when it gets recorded, then it will get turned into video, and then it will actually exist digitally. It does not even, that moment in time does not even exist right now. So you are, let's say here, okay, this blue part represents the last 10 seconds of video that has been recorded on the ground, okay? And there are more such videos before that point. So like, you have camera, you're on the ground, you're recording stuff. Every 10 seconds, you end recording and you make a packet. You say, this is the last 10 seconds of my recording. So what you do is you put that in, you go through the whole same steps here, okay? You put that into the transcoder. You again have all of those streams, because even with live streams, you do have different resolutions, you do have different audio, and it's not all that simple. Your live stream from a match actually goes into a studio, the studio repackages it, and then they add commentary on top of that. The commentators are not on the ground usually, the commentators are on a studio, which is not at the ground. So you have the audio from the ground which is coming in, and then the commentators say their thing on top of that, and then you do have some edit. So there is usually a delay of 30 seconds or 1 minute to edit. If anything really random happens, like somebody streaks naked into the ground or something, that has to be typically edited out, because sports streaming is supposed to be universal. It's not above 18 kind of stuff. So there's a small window for editors to, they will probably switch it with an advertisement, or they will switch it with a different camera angle, or they will just black out if something really bad happens. If there's a bomb that blasts inside a stadium, I mean, God forbid that does not happen, but if it happens, then it's just, so all of that is there, right? So you do all of that, it goes transcoded, and this also turns into all of those different packets and all, but it's continuously happening. There are 10-second chunks coming to you from somewhere, right? So now what really happens is that, like, a video streaming platform, I mean, let's just go with Netflix's case because it was boxing match yesterday. So there is, wherever the camera is, right? So it's kind of streaming these things to Netflix, and it's a continuous process now. So what they will be doing is they will take these, they have this pipeline of 10-second chunks which they are producing, and there are different streams of them, and they are pushing them one by one to the CDN. Now at the CDN, Netflix is pushing to the CDN the chunks one by one. Is updating, so it will just say that, hey, they record it, and they say that 0001.ts, and then they record the next 10 seconds, and they say 0002.ts, and it keeps on happening as the match goes on. It keeps on happening, okay? And this also has a manifest file, but this manifest file is a bit different. So the manifest file is a live manifest, and a live manifest does not start from zero. The live manifest is, I just ask the manifest what is happening right now. So I ask what's happening right now, and the manifest says that, oh, if right now this is what is happening, this TS file, and if you want to watch 10 seconds before, 20 seconds before, all of that, then these are the TS files, and this is what's happening right now. And if you sort of after 30 seconds, if you refresh again, right, just refresh the manifest again, the manifest will have 3 more files in it, okay? So the manifest now is kind of a running doc, okay? And it is like a sliding window. So whenever you read the manifest, you get a list of TS files, and this is the most recently recorded TS file that is available, and these are the last 30 seconds or something, and then the window actually closes behind, so it will not have infinite all the TS files from before. We'll just have a window of maybe 2 minutes or maybe 1 minute or whatever, and it does not know about the future because this actually has not happened. This is t equal to 0 actually. So when you download this kind of a manifest, right, in your video player, it actually starts playing, like it says you are live right now, and it gives you a little bit of seek back, because maybe it's starting to play from this point. It actually is starting to play from this point, okay? And because it has found 30 seconds of buffer, and it starts playing from this point, you can go back maybe a minute for this much stuff, which those TS files are available on the manifest. You can't really go forward because forward does not exist in time at all. So where you're starting to play is actually t minus 30. You're not really starting at t0 because you need that much of buffer to be able to actually play it, right? So like, there is no real live. You're not really seeing what is happening right now. Whatever is happening on the ground, on the sports arena or whatever, is being recorded 30 seconds at a time, 10 seconds at a time, and those pieces are being uploaded somewhere. And your player is asking that CDN that, hey, do you have anything new for me? And it's just keeping on refreshing. What is the next file? What is the next file? What is the next file? And it keeps on downloading those files and it plays them. Now, this is the kind of stuff that you can't really cache all the way down here and all of that. So everybody has to download it from the edge level CDNs itself. And it's challenging because you have to populate all of these different CDN servers. There could be thousands of them for a global event. Even for a single country event, you would probably have 30-35 different CDN servers, and you continuously upload to all of them. Typically for fallbacks, you'd be using multiple CDN providers, and you'd be uploading to all of them, and your client can actually pick between different CDN servers. It'd be using something like AWS CDN, Google CDN, and be using like Akamai CDN. And the player will actually get all the 3 CDN server addresses, and if you try to download a file from one of them and it does not work, you can use the file from somewhere else and all of that. So that's how live streaming works. Live streaming has a live manifest, which only has a small selection of 10 or 20 chunks at every time, and the player just keeps on refreshing the live manifest. And you know, if you want to actually inject an ad here, you just simply you know, instead of sending video files of the actual event, you can start sending some of the chunks which are ads, and the ads will also play. Or you can just tell the player that, hey, instead of playing video chunks, play some ads, and the player will fetch ads from somewhere else and play it. Okay. But yeah, that's how it works. And that's why it's very different from how VOD works. And you can't use all of the caching infrastructure that you have built for movies and TV series while watching live stream events. So yeah, that's about it.